All right. Hello, everyone, and welcome to Practical DevOps Hardware for Small Teams. First off, my name's June. Just a bit of background and context. I make plugins for Unreal Engine, and I do a huge number of Unreal Engine builds across multiple products and platforms and configurations. And because of this, I need a pretty decent amount of build hardware and build automation. It's just me, so I'm targeting, desktop, console, mobile, across multiple engine versions. So it's quite a lot. So I wanted to do this talk today on basically how you can set up your own build automation on premises, and we're going to talk a lot about the hardware side of things. So I'm going to be walking you through a scalable approach to on-premises build hardware. We're going to look a little bit at why cloud is not really the best choice in the game space. And then we're going to do a deep dive on all the stuff you need. And I'm going to be having costings in there so you know how to plan your budgets and so forth. I'm not going to cover the basics of like why do build automation. I'm not going to be covering like specific build software. Those topics are pretty well covered elsewhere. Yeah, the only other thing I wanted to flag is that this setup and my recommendations, while they are sort of generic, I am coming from a C++ Unreal Engine background. If you're doing games that build very quickly or maybe don't have as much like computational requirements in their build, maybe you don't need to go the full way in this setup, but that's just a bit of like background on where this setup comes from. So also, this is a scalable approach, so it's very much a do it once, do it right, and then make it easy to scale as your team's needs grow, so that you don't have to kind of rework your whole CI automation just because you're running at capacity. And the idea is that even as you add more build hardware and more build servers, you can just parallelize your build jobs and across all your build jobs across all of the different machines. It does make it a little more expensive up front. So the minimum setup here is about $6,000. And that's really broken down into one build server and then like one network storage server, which is used so that later on you can share all your build artifacts between build machines. If, with less than $6,000, it's not really enough to cover like the server rack and network server and stuff like that. You can probably still get something out of this talk if that's kind of below your budget. You can look at this for future plans, maybe when you've got funding. You obviously can also just do kind of like a non-scalable solution where you just like buy a build machine and chuck some build software on it, but it's not really scalable and you'll have to change your CI scripts later as you try and scale. And there's also not that much in there for me that would be interesting for me to talk about. And also, with this on-premise setup, if you're in a really, really large organization where you would need thousands of build machines, logistically that becomes difficult to manage in a physical sense. So, can't we just use the cloud? No, cloud is much more expensive, probably a lot more expensive than people realize. And particularly in games, we have like large assets, large repositories. We don't want to have to start from scratch every time we build. So we need disk persistence, and the cloud is not great at doing this. Either our trade-off is basically we'll have really like poor disk performance because they're network attached disks, or you're going to have longer build times because you're going to have to clone onto like the local SSD every time. So let's have a bit of a look at how cloud compares to on-premise for just one Windows build machine. And so if we look at this, this is pretty comparable hardware, same CPU cores, same number of threads, memory is the same, disk size. Disk size is the same, obviously the type is different. In on-premises setup, we've got an NVMe disk that's physically attached. The cloud is obviously network attached. That does have a noticeable impact on your disk performance, which when you're doing things like compilation can slow down your builds. If you've got half the disk performance, that can really count. In this comparison also, I should point out that the on-premises hardware has a GPU in it, and the cloud does not. GPUs in the cloud are going to be even more expensive than what I've listed here. And if we actually do a price comparison, the upfront cost for an on-premises build machine is about $2,700, and just running equivalent hardware in the cloud for 1 month will already blow past that budget. And yeah, so from this, it's pretty obvious that if you're running builds for more than, I think it's 28 days, you can just buy a computer and it's cheaper. Few other things. The disk speeds are from actual testing that I did a little while ago, so the disk speeds are pretty accurate. The upfront cost for this build hardware is from a quote that I got several years ago now, but I did go through my suppliers, the place I get hardware from, and checked, and it's like, yeah, you can build pretty much this hardware for around about that cost. And in terms of the per month cost for on-premise, we're basically just looking at the power usage. And yeah, it's not too much. This is what the graph looks like if you chart the cost over time. And you can see that one of those lines keeps going up, and the other one, it goes up a little bit, but it's almost not perceptible on this graph. So yeah, cloud is really expensive. So let's get into the deep dive of hardware. And we're going to look at what we need. I'm going to run through each of these. Some of these are more optional than others. I'm going to be tracking the minimum and recommended setup costs at the bottom of the screen so you can get an idea of your budgets. The prices are based on actual orders and actual hardware that I've got. And in terms of where we're getting stuff, just so that you know where all these prices are coming from, I use ScorpTech for basically all of my orders. We're going to use eBay for some secondhand stuff. And there's a few other things like Mac Minis that you buy through Apple, and a few esoteric stuff like that. But most of these prices are coming from ScorpTech and stuff like that. And the nice thing there is that from a business perspective, if you know what specs you want on a Windows build machine, you can just tell them the specs and they will build it. And it's I think it's like a $200 fee for them to build it and ship it to you pre-built, which is nice because if you're in a business setting, you don't want to be manually assembling these build machines. So let's kick things off with the physical server rack. This is where we're going to put all of our hardware. This makes the physical side of things, the physical logistics, a lot nicer. It makes it easier to organize and connect everything together. We'll basically be putting all our build machines, everything, we're going to rack all of them up in here. The key things I would say here is measure the physical dimensions of the server rack that you're getting, or compare the dimensions of the server rack you're getting with all of the doors in your building that you need to get it through. I've, on multiple occasions, been trying to get one of these through the doors and then gone, oh, I really hope this fits, and it's been that close. So yeah, so make sure you've measured all of the angles and whatnot so that you can physically get these in. For our enterprise, our Dell servers that we're going to get secondhand, the server rack does need to be 1 meter deep on the dimensions because that's how deep those servers need the server racks need to be. You will find that there are server racks that are only 600 millimeters deep. This is usually used in situations where they're just putting network switches and stuff in and not actual servers. The other thing is that in terms of the widths, you will find that there's server racks that come in either 600 millimeters or 1 meter wide, or maybe it's 800 millimeter wide. Basically, the wider versions of server racks, they just have extra space for network cables on the side, and we really don't need that in what we're doing. You can stick with the 600 millimeter wide, and that's pretty much your safe zone for most doorways in consumer buildings. If you go to 800 millimeter, you might find that it's a lot harder to get it through most buildings. All right. So in terms of actually racking hardware up, there's basically two different types of mounting that we're going to be doing. There's front-mounted hardware, such as network switches. These are much lighter weight. They can basically be held up on just the screws on the front. And then we're going to also be mounting rails for the computers and servers that we're putting in here, which are much heavier. For things that don't rack mount, for like things like Mac Minis, the server rack, or at least the model I bought, the model I listed up there, it comes with 2 trays. You can basically use that to store anything. I use that for the Mac Minis. I also use it for dev kits, which also aren't conventionally like rack mountable. And I will get into this a little bit later, but I do recommend that when you're rack mounting stuff, you have 2 people. It can be quite awkward to be trying to hold the network switch and get the screw in at the same time, and it's wobbly, and 2 people is what I would recommend. For front and, I guess, rear rack-mounted things like network switches, because you can put them on either end, basically the server rack is going to come with a whole bunch of these little clips you see on the left here, and they just clip into these slots at the front or the back, and then you just screw in like that, and you can basically just put the thing in front and screw it through. Note that the numbers in this second picture, you'll see that 34 there. Basically, with the server rack, when you buy it, it'll have a certain RU count, which is rack units. And that's telling you how many of these sections there are in the server rack vertically. And when you've got servers or you've got network switches, they will also have a rack unit. So that can tell you, okay, I've got 39 RUs. My Windows build machine is 4 RUs. You can do the math and figure out, like, okay, this is how many things I can fit, in this server rack. In terms of rails, this is what we call the mounting or the sliding brackets that we use for computers that slide in and out. There are different types of rails depending on what machine that you're going to be rack mounting. We're going to be rack mounting 2 different types of machines in this setup. The first one is basically Dell Enterprise servers, which we're going to get secondhand. In these cases, the Dell rails basically they clip into the sockets. You don't have to screw anything in. And then once the rails are mounted, you'll slide out the inner rails and basically lower the server into the inner rails, and it'll click in, and you'll be able to slide it all the way into the server rack. The reason that we put things on rails and server racks is it makes it really easy to do any hardware maintenance, because you don't have to unrack the whole machine. You can just slide, you can turn it off and unplug it first, and then slide it out, open up the top cover, and do any sort of hardware stuff you need to do without lifting the whole machine out. So the mounting rails and getting in the rails in the first place can be a little bit awkward, but once they're in there, it's a lot more convenient to do maintenance. The rails for the Dell servers, here's a few photos of what it looks like. Basically, that blue clip there is just a clip that hooks into the into those slots that we saw earlier on the front and rear of the rack. And yeah, once it's clipped in there, it's all good. The second type of rail that we're looking at is for the Silverstone RM400, and this is a case that we use for rack mounting our build machines. In our case, we use consumer hardware for build machines because we get a lot more bang for our buck in terms of CPU cores, rather than looking at enterprise options. All consumer hardware cases are equivalent of 4 rack units when you're doing that when you're looking at that vertical space. And this is because most consumer hardware has CPU coolers and whatnot that, if you think about how big a normal consumer PC is, you tilt it on its side, it's about 4 RU. In the case of the rails for the Silverstone, they fully come apart, unlike the Dell ones. You'll be screwing the inner rails onto the actual side of the Silverstone case, and you'll be screwing the outer rails into the server rack, and then you'll basically pull the outer rails out, they'll slide out, and you have to line up the case with the inner rails on it and line the rails in and slide it in, and it'll click in place. The outer rails are very bendy and they can be very hard to line up. So again, I'd recommend you have 2 people. It will make this a lot easier. When we look at how to mount this, there's a few photos. Do take note, these slides will be available later, but take note of which screw holes on the side of the Silverstone case are being used for those inner rails. There's multiple sets, and there's only one that's the actual correct configuration to rack this up. I don't know, and it's not documented anywhere either which one. So when I was first doing this, I had to kind of trial and error my way through which holes I was supposed to use for putting the inner rails on, but it is the ones indicated in this diagram. The outer rails, they don't clip in. You basically just screw in. The screws come with the screws that come with the rails are the correct thread for putting them in, and they just go straight through the holes. You don't need those little clips that we looked at earlier. And finally, on the physical side of things, air conditioning and cooling. So you will need some kind of air conditioning or cooling in the room that you're putting servers in. At least during summer, I find I don't really need the air conditioner on during winter because it's usually cold enough, but during summer, yes. And the servers, especially the racks, especially the enterprise like Dell servers, can be pretty loud with fans. The consumer build hardware isn't too bad because it's the same kind of hardware you'd have under your desk, but the Dell enterprise servers can sound like jet engines when they start up. So I do recommend you put them in a separate room from where you're working. In terms of air conditioning options for like small, medium scale, even for what I'm doing, I find that like portable air conditioners are totally fine, of the type where you can basically put them in the window or you vent the hot air out the window. It's totally fine. They'll usually have like an auto mode, which will automatically engage the air conditioning or dehumidifying when it's needed based on what the temperature you want. I set mine for like 27 degrees, which is, comfortable, but not like over. You don't need to go like 24 or really push the temperature down because the servers can pretty much run anything other than like, you probably don't want like 30 and above. And also, just avoid air conditioners that work by increasing humidity. They're usually like the really cheap air conditioners work this way. We obviously don't want to increase humidity in a room full of servers and electronics for obvious reasons. That would be bad. So that's the physical side of the server rack stuff. And we're going to talk about networking now. So with 10 gig networking, this is optional. I do highly recommend it if you have large builds and intermediate files. You can obviously just use a 1 gig switch and your normal network cables if you want to start out. But having that 10 times faster network transfer can really make a big difference when your builds are starting up or you're transferring build assets between the build machines and the network servers. It might not sound like much, but it can basically bring a 20 gig transfer instead of it taking 2 minutes and 40 seconds all the way down to 16 seconds, which can make a big difference in how quickly you get feedback on your builds. When you're looking at 10 gig networking switches, they're basically going to come in two types, depending on the ports that are on the front of the switch. RJ45, is the network port that you'll all be familiar with on the back of every PC, basically. You use copper cables for them. They're very, very ubiquitous. And then on the other hand, you have SFP+. And this is a connection type that is typically used for fiber optic in data centers. And conventionally, up until, I don't know, probably 5, 10 years ago, 10 gig was very much in the realm of like you have to use like fiber optic to connect any of this stuff up, which is why a lot of the 10 gig switches that are still on the market today will have SFP+ ports on them. The downside of SFP+ is not only do you need a cable, but you also need to have connectors on each end that terminate the fiber optic or copper into the switch. And that makes the SFP switch more expensive in the long run, right? More expensive in the long run. So the RJ45 switch, next slide has some prices on it. So the RJ45 switch is more expensive up front, but in the long run, you don't have to pay for these connectors for every single thing you want to connect into the switch. And keep in mind for the SFP Plus switch is that you would need to get these little connectors, these $72 connectors, even for things that aren't running 10 gig, right? So if you think about like dev kits or things that you haven't put a 10 gig card in, with the RJ45 switch, you can just plug it in with a normal Ethernet cable, right? And also for 10 gig, you need a Cat6a cable, but I mean, it's $11, right? It's not that expensive. So SFP Plus works out to be more expensive in the long run as you scale up. Another thing to keep in mind about 10 gig networking is with Mac Minis, you can't upgrade Mac Mini networking later. Basically, it's part of the order when you buy the Mac Mini. There's an option for adding 10 gig Ethernet onto it. It's like $150. You can't put a PCI Express card in a Mac Mini like we can with the Windows build machine. So if you're not starting out 10 gig and you want the option of doing it later, if you're buying Mac hardware, you will need to kind of future-proof yourself and get that 10 gig option when you're buying the Mac Mini. And internet connectivity, this is going to, obviously on the actual internet connection side, that's going to depend heavily on where you are and your available internet options. In terms of the router used to actually like terminate the internet connection into your network, I use a machine called the Unified Dream Machine, and it's by the same brand as the RJ45 switch that was recommended on the early slides, which means they work together. This seems to have been replaced. The UDM doesn't seem to be sold anymore. The replacements seem to be the UDM Pro, which is rack mounted, which is probably not what you want because your internet connection is probably going to terminate somewhere away from your server rack. Or in the top right here is a picture of the Unify Express, which is probably more practical. The important thing when looking for your router here from Unify is you want to look under cloud gateways. The naming's not great here, but basically you need to have a machine or a device that's running the Unify OS, and that's the thing that gives you this dashboard panel that lets you actually manage all the network and see all the computers on it and what all the ports in the switches are assigned to. So make sure that whatever router you're getting either has this dashboard built in. If you already have a router, Unify does sell machines or little boxes that are just the Unify OS, but in my experience, the Unify routers that you can get, because they're not that much more expensive, but they obviously are tailored at an enterprise market. They are much, much, much more reliable than the consumer routers that you will get. And I would recommend getting one of these over just like some random consumer router because it's probably going to do a lot better in the long run. Let's talk about power. How do we get power to our machines? So there's the obvious way where you can just plug the power cable in. But one of those things that will make your life easier is switched power, which is basically a way of remotely controlling the power outlets in the server rack, which is really helpful because if your build machine stops responding to like remote desktop, you can just turn it off and on again, and then it probably will work. And it can also be great for tracking down how much power each device is using, especially when you start building things out and you're like, where's my power bill like being spent on? Like what's using all the power? These can also measure the power per outlet and give you like an exact wattage, which you can then figure out like, okay, this is how much my power costs per kilowatt. This is how much each machine is costing me. Again, this is totally optional. You don't have to do this when you're starting out. Basically, there's also cheaper options. So the 8-port switch is only it's just under $700. It just does the remote on and off. It doesn't measure the power usage. I started out with not exactly that brand of 8-port switch, but it did start out with just an 8-port switched only option, which got me along quite a while, and then I sort of hit a point where I needed to know like what's using all the power in the server rack, and so I upgraded to the 24-port switched metered power distribution unit, which you can see on the right-hand side here, vertically mounted at the back of the server rack. It's a bit more expensive to go down the metered option than just switched. CyberPower also sell uninterrupted power supplies. You probably don't need a UPS for this kind of workload, right? Like it's usually, UPSs are usually like, when you're running things that have to remain online all the time. The only real case for UPS would be for like the network storage server to allow it to gracefully shut down during a power outage, and that's really only needed if you're going to be putting any like persistent data, like maybe you're putting console SDKs or important Office documents on that storage server, then you might want to get a UPS just to make sure it doesn't like lose data if the power gets cut. Some tips and tricks with this is when you're setting up the PCs is make sure you go on the PC BIOS and configure the turn on after power failure option. This means that regardless of whether the machine has been turned off from like Windows shutdown or has lost power, you can always get them to turn on by just power cycling, by just turning it off and on the power distribution unit, and then the PC BIOS will be like, oh hey, the power's back, and always turn back on. You can also use a power distribution unit to set schedules. So if you've got like a normal office hours and you know the build machines won't be used overnight, you can just configure the power distribution units to just turn all of the power off to all of the build machines and like cut your power bill in half basically, which is quite nice. For Mac OS, however, I do find that the turn on after power failure isn't very reliable, and sometimes they'll just stay off. But on the other hand, their idle power usage is so low that turning them off doesn't actually save you much in terms of kilowatts. So I actually just leave the Mac machines running all the time, and it's fine. Finally, we can get to actually some servers. So all of that's just so that we can actually start plugging things in and having things connected. And the first thing we're going to look at is a network storage server. Basically, when we have multiple build machines and our build jobs have been split up, we need some kind of centralized data storage for sharing build artifacts between build machines, where all of the build scripts can find things in a common place. You can also use this sort of storage server for just, as I mentioned before, just like general data. The key thing here, though, is that we need lots of drive slots so that we can expand our storage later, so we don't get sort of trapped in like running out of disk space. And for our builds, we want to use SSDs because we want to make sure it can keep up with the network requests that are going to be coming in. And consumer PC hardware, it just simply can't handle the number of drives. If you've ever looked at like a consumer PC motherboard, you can maybe get like 6 to 8 SATA connections in there. We want to have the ability, not necessarily to start out with more than that many drives, but we want to have the capacity of expansion later. So it turns out secondhand hardware from eBay is surprisingly cheap and reliable. I've been using secondhand enterprise Dell servers for this sort of workload, as among others, for quite some time, and they are pretty good. And it might sound a little bit weird for us to build stuff using secondhand hardware, but it's important to have the context that a lot of these machines are secondhand because they're coming from large corporations that are decommissioning them in favor of newer models or because they're moving workloads to the cloud. There's nothing actually wrong with the hardware, it's just that the corporation it's coming from doesn't have a need for it anymore. So we basically are looking for a Dell rack server that's got like lots and lots of drive slots or drive bays in it. These will often come with drives, but we don't really care what the drives are. We're going to buy new drives. Often these will have like hard disks, like spinning disks in them, which is just like not suitable for our purpose. We don't super care how many cores they are. You'll see a variety of core counts. We don't care. We're not running builds on this machine. It's just for storage. On the memory side, we do kind of want to aim for like 128 gig, which sounds like a lot. It's basically just any memory that goes here is just used as a disk I/O cache. And the operating system that we'll put on this will basically use all of the available memory to just accelerate that I/O performance above what the SSDs can deliver on their own. You might need to hunt for a bargain on eBay. The price and specs that I found in 2023 were $660. This was for 256 gig of RAM, 2 CPUs, and 16 drive slots. And you might also need to buy the rack mount rails that we talked about earlier separately, depending on the listing. To give you a comparison though, buying equivalent hardware new from Dell can cost you like 8 to 10 grand, so we're saving quite a lot of money by going the eBay route on this one. And so with all that in place, just a short digression on how RAID controllers work. This is not something you'll encounter in consumer hardware, but you will run into it in the enterprise hardware space. Basically, we have lots of disks, and enterprise hardware provides hardware RAID controllers. For Dell, these are branded as PERC. And the problem with these RAID controllers is that the operating system, they can get in the way of the disks and the operating system or motherboard, right? And they can hide the real disks and present them just as like one big virtual disk. The problem is that for the operating system we're going to install, we want, for the operating system we're going to install, it wants to see the disks as disks, so it can do the RAID at a software level. And this is really important. We need to make sure that our RAID controller that's in our Dell server rack has what's called pass-through mode, which is basically a mode where it just presents all the disks you've plugged in as disks to the operating system. But not all Dell hardware RAID controllers support this, especially the older versions, and they will try to force you to make a hardware RAID out of those drives. And that's especially problematic when we've got SSDs, and now the operating system can't see them as SSDs, and things like SSD trim just is completely invisible because it's just seeing it as a giant block of disks. So when you're purchasing these secondhand servers off eBay, try to find out what PERC controller is in the hardware, and check the reference manual for that RAID controller's model to see whether it supports pass-through mode. And if it's not specified, contact the seller beforehand. If you're like me and you didn't realize this was a thing, and you kind of got stuck with a RAID controller that does not support pass-through, it turns out that you can actually flash different firmware onto the hardware RAID controller. So even if it doesn't let you do pass-through mode normally, you can swap out the firmware and do it. There is a guide on doing this, but I do have to say this is absolutely terrifying because every command is prefaced with, if you type the wrong command in, you will brick your server. So it's very, very terrifying. I recommend just making sure that the server you get just has pass-through mode on the hardware RAID controller so you don't have to do this. Also, you do have to physically open up the server and like get the RAID battery out, and it's like under other components so that you can actually override the firmware. It's not fun to have to do this. So looking at the disks that we're going to put in this server, what I went with, and this is probably overkill for a lot of people, but in terms of the operating system, it's two 1 terabyte SSDs in a mirror configuration. And then for the actual bulk storage, the data storage, I went with 7 4 terabyte SSDs. These are configured in RAID with ZFS, and there's a 2-drive redundancy there, which basically means I can lose 2 disks and not lose data. So if 2 disks fail, everything's still fine, and I'll be in a position where I can take out the faulty disk, put a new 4 terabyte disk in, and the operating system will automatically start reslivering the data onto the new disk to build that redundancy back up. This gave me 20 terabytes of SSD storage, which is a lot. It's very fast. I basically took the approach of like, prior to doing this, I had my build storage and storage for documents kind of just like scattered all over the place on wherever I could scrounge off my build machines and stuff, and it wasn't great. So I really did probably do overkill of like, I don't want to think about this problem again. And unlike CPU and memory, storage is one of those things that it's a bit more annoying to upgrade because you do have to like migrate data, right? Adding new CPUs or adding new machines that have more memory or whatever is not really a big interruption, but doing data migration can mean downtime if you have to like copy things across and pause things while that's happening. But yeah, you might want to start out with a smaller disk array to reduce costs. And obviously, even if you do, you're going to have all of those spare drive bays so that in future, if you want to be like, okay, cool, we're getting close to our storage limit, you can buy another set of disks and mirror all of the things onto mirror all the data onto the the bigger drive array. The specific model of SSD disks here, they have gone up way in price from like $400 to $700. I don't understand, but there are other 4 terabyte SSDs you can get on ScorpTech for $360. So this is still a pretty reasonable price point or price estimate. And just a note about the minimum here. For the minimum setup, I'm assuming 2 4 terabyte SSDs, which is probably good enough to get you started. And the recommended one here is looking at that 7 terabyte, 7 by 4 terabyte. I will also say quickly, there's no need for NVMe disks or M2 disks on the RAID on the network storage server. SSDs can keep up with a 10 gig network. NVMe speed will go to waste basically because the network will be your bottleneck at that point. Your NVMe's are so fast that even with a 10 gig network, they can outpace the network by a wide margin. So SSDs are totally fine. In terms of the operating system, there's a very good NAS operating system called TrueNAS Scale. This takes a lot of the pain out of managing a storage server. It has a nice UI for setting up Windows network shares, which you're going to need so that your build machines can actually reach the network server. It also has a bunch of options for backup and replication offsite and data redundancy. And it takes a lot of the pain out of doing the NAS management. And this is some screenshots of what it looks like, so you can get an idea of what this looks like. Basically, it's a nice dashboard where you can click around and set things up. Everything's broken down into data sets, so you'll make a pool, you'll get all of this together, makes a storage pool, and then you basically create data sets underneath that pool. And you can do things like setting quotas and setting up shares per data set, as well as configuring offsite replication per data set. You can also take snapshots, which I find is quite useful if I've got like Unreal Engine. I clone that into a data set, and then I can instantly make a copy by just snapshotting it and creating a new data set from the snapshot. And there's like 0 copy time because it's not actually having to copy any data; it's just doing copy on write basically. And so that can be nice as well. It has a UI for setting up all your network shares. In my case, I do run Active Directory or Windows Active Directory, which can simplify the permissions so that your build servers don't run into like file permission errors. You probably don't have to do that, but that's just something I thought I would note. You can probably just set all the file permissions to everyone and it'll be fine. What else? And this is just a screenshot of the backup data replication side of things, so that if you are storing like those Office documents or big assets that are not necessarily build artifacts, you can upload them to the cloud on a regular basis. You can sync to other TrueNAS servers elsewhere offsite. Yeah. So now we finally get to talk about build machines after I've talked about all the other stuff. And this section's actually fairly short because it's fairly straightforward. Windows build machines, the specs are going to depend on your workload. For Unreal Engine, what I found is that a 12-core, 24-thread AMD Ryzen, 64 gig of RAM, and a 2 terabyte NVMe, which in this case we do want NVMe because it's going to be the C drive. You're going to be doing a lot of like local disk access. And then a 10 gig PCI Express network card if you're doing 10 gig network stuff. In terms of cores, it's cheaper to go for a lower core count Ryzen than go to the Threadripper and scale out horizontally over machines, which will also give you the ability to run a lot more things in parallel, especially with Unreal Engine that likes to use one machine per job. Then it's a lot cheaper to go for like that 12-core Ryzen than just like the Threadrippers, because the Threadrippers, they're a lot more expensive, but they're also a lot more expensive per core. So the cores are cheaper for something that's more a core that you would find in a consumer, not like pro workstation machine. in terms of the costs, this works out to be about $2,500 for the PC, that includes the server rack case. There's $130 in there for the 10 gig card and $80 for the rack mount rails. And so on the budget, we're tracking at the bottom. That's just one build machine, or one Windows build machine there. Make sure if you're asking for these to be pre-built from like ScoreTep that you specifically mentioned, you want it in that rack-mounted case so they know that you don't just want it in a normal consumer case. For macOS, I use Mac Minis for the Unreal builds. Horizontally scaling by like buying lots of Mac Minis is really the best way to get like lots of Mac cores. Going for like larger Mac machines or things outside Mac Mini, it doesn't really get you that many more cores, and if you're doing C++ or Unreal Engine compilation, cores are what you care about. So you're better off just buying lots of Mac Minis. The storage options for Mac Minis, Apple overcharges horribly for storage. So I would recommend that if you are finding you're running out of disk space on the Mac Minis, that you go and get an NVMe disk separately and a PCI Express USB 4 enclosure, and that will give you a pretty fast external disk for the Mac Minis at a fraction of the price that Apple will charge. So wrapping up, in terms of setup price, infrastructure comparison, the minimal setup is just under $6,000. We've got that physical, that should say server rack. That's a physical server rack, not a physical rack server. A physical server rack. We've got that network storage server with 2 4TB disks and 1 Windows build machine in that cost. That's pretty much good to get you started. In terms of something that looks closer to what I have, again, that physical server rack, the 10 gig switch power, that network server with a lot more storage, and a Windows build machine runs you about just under 12 grand. I have 4 Windows build machines and 2 Mac Minis, so you can probably do the math and figure out what that is on top of that. And yeah, that's pretty much it from me. Thanks. Any questions that people might have, I'm happy to go into. Yes.
What about...
We've got a microphone, just, I think, bring it down. Thanks.
Yeah, I'm just... what about leveraging workstations? So let's say, for example, we've got 100 computers, and 50% of them are not being used at any given time. What kind of setup do we need to go for?
That's probably going to be very engine specific. At least in the Unreal Engine space, I would recommend looking at Unreal Build Accelerator. That's a very good option there. Yeah, it's tricky because you need to make sure that like when the machines are actually in use that you don't schedule things on it, and that can be kind of a bit hard to find, I think, for maybe conventional CI/CD software. But the Unreal Build Accelerator is, at least for C++ compilation, might fit the job there. Incredibuild definitely would work there, but it's a lot more expensive. So.
Okay, cheers.
Thanks. Anyone else? All right. Well, in that case, thank you very much, everyone, for coming along. I'll be out the front if you want to chat to me. The slides aren't up on that link yet, but they will be probably by either tonight or tomorrow. And yeah, thank you very much.